Hi, hope you're well. In this video, we want to solve one of Stanford problems with Wilson's method or theorem. But before that, you should know congruency is what, and I want to teach you congruency is what, and then we want to work on Wilson's theorem, and after that we want to solve this problem. So if you know congruency is what, you can use my timestamps in the description. And for example, if you know that, you can pass this part to go to Wilson theorem. And if you know Wilson's theorem, you can pass to the part that only straightforward solve the problem and only straightforward see how we can solve this problem by using Wilson's theorem and congruencies. So if I explain like this, the students that don't know congruency, they learn. The students don't know Wilson's theorem, they learn. And students that know these things, they can go straight forward to the part of solving the problem. Okay, so at first let me explain for you a little congruency that it is what. So it is what, for example, suppose we want to consider numbers a when divided by 2. They are even or they are odd. A can be even or 2k plus 1. So if we want to show it with congruency, it is remainder. A when divided by 2, the remainder is 1 or 0. So or it is exactly like this. In the past, you've showed, for example, a2k plus 1. It means a when divided by 2, they say, is congruent to 0. Means they have same remainder. Both of them are even, or a1. So if we consider mod 2, we say 0 is congruent to 2, is congruent to 4. All of them are even numbers. One important thing, for example, mod 2 is you can add by 2 or subtract 2 from the numbers. So this one, 6, 8, you can write on to -4 and so on from here and so on from here. Also, we can write 1 is congruent to 3, is congruent to 5. You can add by 2. Is congruent by -1 and by -3 and so on from here. 7, 9, you can write. Okay, so it means here, for example, mod 2. So when you see 2k, a is congruent to 0, 2k plus 1 is congruent to 1. This part is remainder. You can also do, for example, for 7, if we have 25 mod 7, you can add by 7. For example, 32, you can add 39. And here you can subtract 7, it will be 18. You subtract by 7, it will be 11. You subtract by 7, 4. You subtract by 7, -3. All of them have same remainders, and the remainders are equal to 4 when divided by 7. So that's a good thing. We can add by 7 or subtract 7 from the numbers when we want to consider mod 7. There are some rules. Unfortunately, the rules are like equal things. For example, equation. What are they? For example, if A is congruent to B, like equality, you can mod any number. For example, mod M. You can add two numbers, for example, M to equal numbers, or also n to both sides. And for example, you can subtract. You can say, okay, we know A is congruent to B mod M. You can subtract n from both sides. This one like equality, or you can multiply by n. Okay, so you can use these rules also so remember, plus subtraction and multiplication. Always we have like equality. Only for division it has some special rules, but because in this problem we don't need that, I only work with these things. So only here, for example, like what someone says, let's solve, for example, some problems with this congruency. Someone says 2a is congruent to 1 mod what number 5, and then a is what. Let's solve one problem with this idea congruency and see how it can be useful. So if I solve this one, for example, solution number 1, I multiply both sides by 3, like equality. So 6a is congruent to 3 mod 5. And then we can say what? 6 is what this coefficient is 1 mod 5, because as you remember I said if it is mod 5 you can subtract or add 5 to this number. So 6 is 1, so instead of 6 you can write 1, because 6 times a is 1 times a product, and you can use it in congruency. So a is 3 mod 5. One other way is that you can replace, but solution number 1 is so much better. You say the remainder when a divided by 5 is 0, 1, 2, 3, 4. 5 remainders we can have. So 2 times 0, 2a should be what? Should be 1 mod 5 by assumption. So 2 times 0 is not good, 2 times 1 is 2 is not good, 2 times 2 is 4, 4 is not good, 2 times 3, 6, 6 is good, 2 times 4, 8, 8 is 3 mod 5, so it is bad, so we find this. Solution number 3. Suppose that we multiply both sides by 2, so it will be 4a is congruent to 1 mod 5. 6 was good. Why? Because it was 1 more than 5 and you replace it with 1. 4 also is good because it is 1 less than 5. So you say what? 4 is congruent to what mod 5? Can you guess? 1 or no? Subtract 5 from this, it will be what? Yes, negative 1. So if we replace here, negative a is congruent to 1 mod 5. And, when you multiply by 2, we should also write 2 here because it is 1, multiply both sides by 2, like equation. So negative a is congruent to 2, so a is congruent. If we multiply both sides by negative 1, it will be negative 2, and if you add 5 to this, 5 minus 2 will be 3, so mod 5. So sometimes in 2 steps also you can reach this, but the important thing is to change the coefficient to 1 or negative 1. How? By multiplying. As I said, for dividing, it has some rules you should pay attention. In this problem, we don't need that, so I only tell you the things that are useful. So we are ready to see what's Wilson's theorem. Wilson's theorem says, suppose P is prime, then it says P minus 1 factorial mod P is negative 1. Look, in this video, I don't want to prove Wilson's theorem. I just want to check some numbers to understand and use that. If you want to prove that, you should know multiplicative inverse. I will release some videos about that to understand is what, and then we prove in next videos. Okay, so please don't forget to subscribe to our next videos and for proving things, for learning new ideas. Okay, it means what? For example, let's consider P is 2. 2 minus 1 factorial. 1 factorial is congruent to negative 1 mod 2. Yes, it's okay because 1, if you subtract 2 from that by congruency is okay. Let me tell you something. For example, if you want to check some congruencies, one way is to subtract these, for example, one side from other side. So you say 1 minus minus 1. Is it multiple of 2? Because they have same remainder, their difference should be multiple of 2. It's 2 and it's okay. So for P3 also, by the way, I told you you can say y. If you subtract 2 from that, it will be negative 1 mod 2. So it's okay. For P3, 2 factorial is negative 1 mod 3. So let's check, is it correct or not? It's obvious because it is 2. 2 minus 1 is 3. Multiply 3. Or you can say subtract 3 from 2, negative 1. Or, as I said, left side minus right side should be multiple of 3. The other things, the other way you can check. So it's second way, or you can subtract 3 from this. Let's check, for example, for one more, P5, 4 factorial is congruent to negative 1 mod 5. So if we check 4 factorial mod 5, it's 24. 24 minus 1, if we check with this way, is what? 25 is multiple of 5. So Wilson's theorem is this. We want to only, in this video, we want to check application of Wilson's theorem. Now you know it is what, but you don't know the proof. It's not important. In next videos, if you want to know the proof, you can comment and below this video, and I will release another video to explain and prove it completely, prove Wilson's theorem. So let's solve. Now we are ready to solve problem. The problem says let S equal to 1 plus 2 plus 3 plus 100. There are around 5 or 6 important identities that you should memorize. One of them, the easiest one, is this. It's 1 to n is n times n plus 1 over 2. 100 times 101 over 2. And if we divide, it will be 50 times 101. And now we want to find what? Find this mod this. So you say 100 factorial over 4 factorial mod s is what? So we've learned congruency until the things that is important and we want to apply here. So we want to find mod s. S is what? S is 50 times 101. So when we have two parts like this, one way, when you want to find remainder, you want to find remainder of 100 factorial over 4 factorial when divided by s. So because s is product of these two numbers and they are coprime, one way is to find remainder when divided by this one, when divided by this one, and then use these two things to reach the whole term. So how we can do this? You can use this new idea in congruencies if you've not seen that so yet. Okay, so let's solve this one. At first, mod 50 is so much obvious. 100 factorial over 4 factorial mod 50. Okay, so if you pay attention, it is multiple of 50. Why? Because, for example, look, if we write all numbers, you write 50 and until 4 factorial you can divide. So if I write 1, 2, 3, 4, it will be 3, it will be 5 times 6 times 7 times 2, 100. And it's obvious that it's multiple of 50 because it's an integer. It's multiple of 50, multiple of 100. So this one is congruent to 0. Now let's solve harder parts. And in the next case, we want to use Wilson's theorem, and you will see how important Wilson's theorem is. So this one, mod 101. So I want to find this, so I consider it as x. So do you remember I said we have product, subtraction, and adding, like equation, except for division. I said we have some different rules, and I will tell you in my next videos. So here, if I multiply both sides by 4 factorial, then left side will be 100 factorial, right side will be 4 factorial is what? 24. It will be 24x mod what? Mod 101. So all things we consider is mod 101. So sometimes I don't write this. No, that all of them are mod 101. So 24x is congruent to 100 factorial, and 100 factorial is congruent to what? By this case, we want to use Wilson's theorem. Can you tell me it is what mod 101? Wilson theorem. If P is a prime, P minus 1 factorial is negative 1 mod P. Here, 101 is a prime number. It is P minus 1. So great. It will be negative 1. So here, we've applied Wilson's theorem. We don't need that anymore. And now we should be able to work with congruencies. It's so much important to get good at congruencies because it's so much useful in many exams. So 24x is congruent to negative 1. Now, as in the previous parts, I showed you how we want to reach coefficient 1 or negative 1. So we want to multiply it to reach near 101. So one thing is to multiply it by 4. It will be 96x negative 4 mod 101. But 96 is what? As you remember, I said you can subtract 100 or add 100. If I subtract 100 from this, 96 minus 100 is what? 101, sorry. We are working with 101. If you subtract 101 from that, it will be what? It will be negative 5. So now it's better. Little 5x is congruent to negative 4 mod 101. So you can multiply it by negative 20. So the left side will be 100x. So look, it's the nearest number 100 to 101, and you can reach that. It will be what? Negative 20 times negative 4, 80 mod 101. Okay, so this one is what? If we consider, let's consider, we can multiply by plus 20. We don't need, because let me show you negative 120. It will be negative 80. Also, that case was okay, but why it's a little better? You say negative 100. If you add, you want to say it is mod 101 is what? If you add, it will be exactly 1. In that case, it will be negative 1, and you should multiply by negative 1 again. So here, we can say it is 1x is congruent to negative 80. And if you add 101 to this, it will be 21 mod 101. So great! We found the remainder of x when divided by 101 and when divided by 50. So x is 0 mod 50 and x is what? 21 mod 101. In general, if you want to solve these things, we call an important thing Chinese remainder theorem. You can also read that in next videos. I will completely describe this. So please don't forget to subscribe to have all these theorems and important things. So, but here with only our knowledge, I want to solve this, nothing more. So x is 50. I can say what? I can say, okay, because x is 50, the remainder is 0 when divided by 50. So we can say x is equal to 50q, and I replace it here. 50q is congruent to 21. Okay, so again, similar to previous problems. What number? I want to find q. So I want to multiply it to reach near 101. We should multiply it by what? Can you guess? Exactly, by 2. 100q is congruent to 42 mod 101. So 100 is what? 100 when you divide by 101. If you subtract 101 from this, it will be negative 1. So it will be negative q is congruent to 42 mod 101. So if you multiply by negative 1, q is congruent to negative 42 mod. Okay, negative 42. If we add 101, it will be 859. Okay, and if I now replace, q is what? Q will be 101k plus 59. And now if I replace it, let me write this with green. X was 50Q, it's 50 times 101. K plus 59 times 101. S was what? S was 50 times 101. So it will be what? It will be 50 times 101. K plus 50 times 59. The problem wants what? Wants 50 times 59, the remainder. It says x is what? X was what? 100 factorial over 4 factorial. It says what is this? Mod s. S is this. So it's 50 times 59. And if you multiply 0, 5 times 9, 45, we have 4, 5 times 5, 25, plus 4, 29. Okay, so we've solved this Stanford problem, one of the top universities. I will release other problems of Stanford, Harvard that helps you also to apply for these universities. So if you enjoyed this video, please like and subscribe and comment and tell me what things you don't know, you need what videos to improve your mathematics. And thanks for watching my videos and for your support. See you in my next videos. Bye.